Vector addition and subtraction. Two vectors A and B can be added together, which gives another vector C. So here you can see that vector A and B we are adding here, and it gives the another vector C. So vector addition can be carried out component by component. So if A equal to AX, AY, AZ and B equal to BX, BY, BZ, so the addition will be like that, C equal to A plus B. So component by component is adding here AX, unit vector AX, plus AY, unit vector AY, plus AZ, unit vector AZ, plus another vector component BX, AX, BY, AY, BZ and AZ. So you can take the common unit vectors like AX and AX from this component of the vector. So it will look like AX plus BX unit vector AX. Same, we take this AY unit vector and adding these components AY plus BY plus AZ plus BZ unit vector AZ. Vector addition follows the parallelogram law as shown in figure 1. You can see that unit vector B, unit vector A, so gives its resultant here, which is C equal to A plus B. Now join these lines which show that it's a parallelogram. So this is the vector addition is shown by parallelogram law, and this figure B is showing head to tail rule. So this the vector A is here, and the another vector tail is at the head of this vector A, and the resultant is here C, which gives A plus B. This is the vector addition. Now rule for subtraction of vectors. We can express the subtraction of the vectors like that. If we have to calculate A minus B, so we can write it as A plus minus B. That means we are just reversing the direction of the vector B. So we can add like that the vectors. So here we have this unit, this is vector A, here we have vector B. So we just reverse the direction of this vector B this side. Now it is now minus B, and the resultant is D, which gives you A minus B. And by head to tail rule, you can see that this is the vector B, this is vector A, and it gives the difference another vector D. So this is the subtraction of vectors. You can write it as. Now three basic laws of algebra obeyed by any given vectors A, B and C, which is summarized as follows. Here we have the laws, here the addition and multiplication. So it follows commutative law. Commutative law states that A plus B is equal to B plus A, and multiplication is Ka and Ak. So it gives you same result as. So now associative law, A plus bracket B plus C is equal to A plus B bracket close plus C, and in case of multiplication you have K in bracket LA, now in bracket KL, and outside the bracket is A. Distributive law is K A plus B. Now multiply K inside of the bracket, you will have K A plus KB, where K and L are scalars. So these are the three laws of algebra, which is just followed by any given vectors: commutative law, associative law and distributive law. Now position and distance vectors. Position vectors RP, you can say radius vector of point P, is defined as directed from origin to point P. So you can write the position vector as x ax plus y ay plus z az. Position vector is very useful in defining the position in space. So we will use this position vector in electric field, where we have to define its position in a space. For example, point 345 and its position vector 3ax plus 4ay plus 5az is shown in figure this. So here this is the position vector is showing here, which is directed from origin to point P, and we have this point P 3, 4 and 5. That means we have this vector in direction of x, which is x equal to 3, and 4 in the direction of y, so it is y equal to 4, and 5 is z, which is here, z equal to 5. So its position is here, and its position vector is shown from origin to this point, that is showing rp, and you can write it as for example, I'm showing here. So this is origin is 0, 0 and 0. This is point P 3, 4 and 5. So you have to calculate the position vector rp. So you just subtract this position of point P and origin. So 3 minus 0, unit vector ax plus 4 minus 0, unit vector ay plus 5 minus 0, unit vector az. So the position vector rp is 3ax plus 4ay plus 5az. So this is the position vector.